In today's lecture, I will show you that how to design the equivalent circuit of a split ring resonator. After studying this tutorial, you will be able to design equivalent circuit of any antenna or microwave structure. So here you can see that there are two split rings and a thin wire. The split rings are at the top of the dielectric slab and the thin wire is placed at the bottom of the dielectric slab. So this whole arrangement was proposed by Voslego and it is implemented by John Pendry. The conductor portion of this split ring shows the inductive part and there is a gap in between them, so it shows the capacitance. Similarly, the second split ring will also behave the same. And for the third thin wire, you can see that there is a conducting portion above the slab and there is a conducting portion at the bottom of the slab and a dielectric material in between them. So it is also behave like a combination of capacitor and inductor. So this split ring and this gap will make a parallel combination of inductor and capacitor. Similarly, this second split ring and this gap will make the another parallel combination of inductor and capacitor, and this top and bottom arrangement will make the combination of T network of inductor and a capacitor. So we will implement this on the ADS software. In my previous videos, you can see the modeling of split ring resonator. Here I am showing the direct results. This is the magnitude of S11 and it's a simple S11 value in dB. If you want to extract the parameter of metamaterial unit cell, that time you have to require these magnitude of S11. But if you want to make the equivalent circuit, then only see this S11 value in dB. So here you can see it is synchronized at 10 gigahertz and near about 12.5 gigahertz, or we can take the marker. So it is 13 gigahertz frequency. So we will try to make our circuit, make the equivalent circuit at 13 gigahertz frequency band. This figure shows the equivalent circuit diagram of a split ring resonator. Here there is, this represents the first split ring. It's a combination of L and C. This is second split ring. It's again combination of L and C. And here two inductors, the surface inductance and the bottom strip line inductance. And there is a capacitance in between them. So the whole architecture represents the split ring resonator. Initially, the value of inductance and the capacitance will take 1, and after optimization, when they will match with the S parameters of the actual circuit, that time we will get the final values of these inductor and capacitor. We are not strict only on this circuit. If you are supposed to make some different kind of circuit according to your logic, like you can place two inductor and two capacitor in series for a split ring resonator, this circuit would also good, there is no problem. The only thing is that when you will optimize or tune your parameters or tune the value of inductor and capacitor, that time you will find some different values. But the combination like series and parallel, when you will calculate the series or parallel combination of inductor, you will find exactly same value what we will found here. Okay, because we have to match or optimize or tune the values with the S parameter values. So our circuit should be synchronized at the S parameter values. We will create our equivalent circuit model on ADS software, that is Advanced Design System. and its version is 2014. So when you will open the ADS and create new worksheet, you will find this kind of a screen. Now just click on this schematic diagram. So when you will click on schematic diagram, it will ask for your file name. Now first we will insert the components. So we have to insert the 4 inductors and 3 capacitors. 1, 2, 3, 4. Rotate it. Now insert the capacitor. Rotate. Then just do copy and paste. This is connecting wire. Connect all these. Now place the ground. We have to require 2 more ground. Now we have to connect the terminal, source terminal and termination terminal. So just go on insert and component library. And here search term. So in term this simulation type terminal. So we place 2 terminals here. Now connect them by ground and rest of the circuit. So the circuit modeling part is completed. Now here you can see that we will assign the variable. So just click on VAR and place it here. Now double click on this inductor, name it L1 and its value is in nanohenry. Apply. Okay. So here you will find that L equal to L1 in nanohenry. It will be C1 in picofarad. This will be L2 nanohenry. L3 and L4. So we assign the variable values to L1, L2, L3 and L4. Similarly, we have already assigned C1 and now we will assign to C2 in picofarad and C3 in picofarad. Now double click on this variable and name here, replace the x by L1, click on add, then L2, add. So keep in mind that variable value will remain same 1 and here none will be present. So we have add L1, L2, L3 and L4. Similarly, we have to add C1, C2 and C3. So here you will find all the values L1, L2, L3, L4, C1, C2, C3. So all these are assigned in the variable block. Now we have to require the S parameters because S parameters are the main component. So again, go in the insert component library and search S underscore param. So here you can find S parameter simulation. Double click on it and place it. Now we will adjust the values. So our split ring resonator was resonant at 12 gigahertz frequency. So I will start from 5 gigahertz and stop it at 15 gigahertz. Step size is 1 and number of points make 1000. Apply. OK. Now we have to decide our goal. So again go on insert component library and write here optim. So in optim we will select this optim slash stat and when we will do the double click on optimization we will found that optimization type. So here you can see there are a lot of algorithms. So you can found or you can choose any one of them. I am not changing here at all. I am keeping it random as it is. And in number of iterations, I am giving 5000. We have set the optimization. Now for optimization, we will decide our goal. So in lumped component window, just search the again optim. So here you can see that optim state DOE is appear and here you can find that goal. So we have to decide two goals, one for S11 and another for S21. So we choose two goals. For goal 1, when we double click on it, we found this expression. So we have to find out S11. So this S11 should be in dB and write S, then 1 comma 1 and close both the brackets. The analysis is ST1. Now we have to choose the frequency, and for this frequency we have to decide the limit 1. So it should be less than maximum value is -10, and the starting minimum frequency is 10G, and the maximum frequency is 15G. So what this limit says that the value of S11 should be less than -10 dB in between 10 to 15 gigahertz frequency band. So apply. Okay. Now for goal to dB S21, the analysis is ST1, choose frequency. The first limit is it will be greater than the minimum value is -1.15 from 10G to 15G, and add limit. The second limit is less than, and the maximum value is -15 from 5G to 10 point to 9.5G. So what it represents that there is two limits for S21. It should be less value in between 10G to 15G because S11 is high at in between this range, and for the rest of the band, that is from 0 to 10. So it can be -15 GB. That is the maximum value. So here we are not taking exactly it at 10 because to avoid the overlapping. We choose it from 5G to 9.5G. So apply. Okay. So we have set the goals. Now here at the top, there is option simulate. Right. We will select it, and then the third option simulation variable setup. So when we will select it, we have all these variables. So for tuning, we have to select all these things, and the minimum value is 0.5 OK, and maximum value is up to 1000. Similarly, for optimization, we will choose all these values, and minimum is 0.5 OK, and maximum is 1000. So this is the range of our component. Apply OK. So we have found that all the value of the variables are changed, and now we will just click on simulate. So now here we can see that optimization is completed, and here you can see the graph of S11 and S21. Okay, so when you will click on the results, just select the rectangular plot, and when you will click on this screen, you will get this table. Here you have to choose S11 in dB and S21 also in dB, then OK. So you will get this graph. Here you can see that S11 parameters are resonant at 12.2 or 12.3 gigahertz, and the at that and the value of S21 at that time is almost 0. So here we found the value of, so here we get the value of L1, L2, L3, L4, C1, C2, C3. So these are the our final values what we have to require when we will take the inductor and capacitors or of given values. We will found that the resonant frequency of this circuit is 12.2 or 12.3 gigahertz. So we can say that this is the equivalent circuit of the given structure. Now, in the similar way, you can design any kind of equivalent circuit of any other antenna or electromagnetic devices. If you change your geometry, like if you use two inductor and two capacitors in series for the same SRR, that time you will found some different values of L and C, so that the circuit should be resonant at 12.3 gigahertz. Some error in your reading, you just start tuning, and by changing these values you will found that the graph is change, and you can tune the graph according to your desired frequency. So I am not disturbing all these. So you can also choose the option of tuning. Now this lecture is completed. So if you have any query, please text me. Thank you.